Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to tonight's video. And the title of this one is You Dropped the Bomb on Me. Yes, you dropped the bomb on me. And what do we refer to when I refer to a meteorological bomb? A bomb is a storm that intensifies on the order of 24 millibars. A drop of 24 millibars central pressure within a 24-hour period. And that's exactly what we're looking at. We're looking at bombogenesis, or a very strong cyclone moving from off the southeast coast up off the mid-Atlantic and up towards New England. So I figured this was a great name for the video tonight because it's so appropriate. Now, this storm is still potentially there for the 28th, this Friday, and the 29th, this Saturday of January 2022. So let's get right into it. The last video I made was 2 days ago, so let's see what's changed since then. Before we begin on looking at the various weather models tonight, I explained a little bit about this in the last video, and I wanted to really hone in on this because this is so critically important as far as the surface storm, the surface low pressure track to the East Coast. So really what I'm focusing in on are a couple different terms here with these upper level troughs. Now these upper level troughs provide that necessary energy to really kick off a very strong surface cyclone. And these troughs, I'm most interested in looking at the mid-level atmosphere troughs at 500 millibars or 18,000 feet. So the upper left-hand graphic shows what is considered a positively tilted trough. And let me get my tool out here, and I'll highlight some points here. All right, so you notice how this black dashed line, it orientates itself. The trough axis is the black dashed line, by the way. And this trough axis orientates itself from northeast to southwest. That's a positively tilted trough. Okay, positively tilted troughs are associated with weaker storm systems. And we did get some appreciable amounts of snowfall just this past weekend. That was the 21st and 22nd of January 2022, because we had one of these actual positively tilted troughs move from the Ohio Valley to the Mid-Atlantic and actually kicked off and enhanced a storm system off the coast. So positively tilted troughs, although they are associated with weaker storm systems, they still can be enough to kick off precipitation and fairly decent amounts of precipitation reaching the surface. A negatively tilted trough is a much more intense trough, and the orientation of this dashed black line, this trough axis, is from northwest to southeast. And when you get a negatively tilted trough, that indicates a storm system has reached maturity. It's much more intense. You also get this strong differential advection of vorticity at the mid-levels of the atmosphere, as well as thermal or temperature advection in the lower troposphere, closer to where we live. And this overall increases the thermodynamic instability, and that storm system is going to feed off this differential advection. It's going to intensify using the energy differences in not only the vorticity values, but as well as those temperature differences of the surface to really energize itself. Now the graphics on the left here, I did want to mention that these are courtesy of the weatherprediction.com website, courtesy of Jeff Habe. Right, so now let's take a look at the explanation again on the importance of looking at 300 millibars or 30,000 feet above the ground, where we have these phenomena known as jet streaks. And when you get these jet streaks, basically what they are, they're basically an area of accelerated wind speeds within the main jet axis or jet core. And certain quadrants, as I explained in the last video, represent rising air motion from the ground all the way up into the upper atmosphere. And other quadrants of this jet streak are associated with sinking air motion. Right, so here's the general diagram of a jet streak, where the left front and the right rear quadrants of this jet streak promote rising air motion, upper level divergence, removal of mass. So if you're located in the left front quadrant where this rising air is over here, or in the right rear quadrant where the rising air is over here, that's going to indicate you're in a favorable location of the jet streak to get rising air motion, clouds, and precipitation. On the other hand, if you're in the right front or the left rear quadrant of the jet streak, those are generally associated with areas in the atmosphere where the air sinks. And when the air sinks in the atmosphere, it tends to dry out, and you generally tend to have much drier weather conditions. So it's important to pay attention to the location of these jet streaks. This was the forecast the other day, and I kind of hinted at this jet streak, this brown coloring here. Now we look at the overall, we go back to these mid-level troughs, these shortwave troughs. Again, just a reminder, out ahead of these shortwave troughs, we typically have areas that are known as, that contain positive vorticity advection, or PVA. And when you have PVA out ahead of these shortwave trough axes, it generally results in rising air motion, and you get a storm system to develop at the surface. You get a lot of moisture to rise and get these clouds and get these precipitation. Behind the shortwave trough axis, you have the opposite effect, where you have this term called negative vorticity advection, where lower values of vorticity are moving into your area, and you get sinking air motion. You get upper level convergence. The air is coming together high up about 300 millibars or 30,000 feet. When this air comes together, it sinks, and that generally results in that surface high pressure and nice weather, okay, behind the shortwave trough axis. So now let's take a look at, before we get to the graphics, I wanted to mention this chart. All right. I've been taking a look the last couple days. I like to look back at previous storms and the general path, storm tracks, the path they took. And the graphic here on the left-hand side is from December 26th, 2004. This was the day after Christmas. You notice this area of low pressure at the surface. The storm system's developing. The pressure's starting to lower, the central pressure. And this particular storm in December 2004 produced quite a bit of snowfall across Hampton Road cities. Now look at the graphic here in the middle. This is from the December 26, 2010 storm. Look at where this deepening area or intensifying area of low pressure, the storm system's getting its act together, it's getting stronger right off the coast of North Carolina in December of 2010. Now this particular storm ended up producing over, December 26, 2010, this produced 14.2 inches of snow on Virginia Beach. Now let's take a look at the right-hand graphic showing the surface analysis. This is a surface weather map for 7 a.m. Eastern Time on January 4th, 2018. And look at how tightly packed these solid lines are, these isobars, lines of equibarometric pressure. This storm system basically passed just to the east-northeast of Hampton Roads, really of southeast Virginia. This storm produced 8 to 10 inches of snow and produced blizzard-like conditions for Virginia Beach and Norfolk. So we look at the past storms, and we look at how these storm systems all made similar tracks just off the mid-Atlantic coast, okay? And we notice how intense they are. And the results, I believe we got 6 to 7 inches on this particular storm in December 2004. I'd have to go back and verify that. But I know for a fact, December 2010, we got 14 inches of snow in Hampton Road cities. And then the graphic on the right, January 2018, we ended up getting 8 to 10 inches of snow. And it was just a phenomenal storm. So these storms have a lot in common of what I can see for the upcoming weekend storm. It just gives you perspective on the potential. And I always emphasize potential because it's not a guarantee. Now let's take a look at the weather models. Let's take a look at the GFS model first for Friday the 28th of January 2022. Now in tonight's presentation, I'm including the thickness chart, surface pressure features on the left of each slide. And on the right-hand side, I'm going to depict where that shortwave trough is located and the tilt of that shortwave trough. So I got a side-by-side comparison through each slide deck. Okay. So let's go ahead and get into first starting off for Friday afternoon. This Friday afternoon, 28 January at 1 p.m. Eastern Time, 1,012 millibar low pressure is just getting itself developed east of Jacksonville, Florida. We have a cold upper level trough approaching from the northwest, working its way south with much colder air. And then here is the 500 millibar, 18,000 foot vorticity chart along with the position of the shortwave trough. So the shortwave trough axis Friday afternoon extends from the Great Lakes right on down through southeast Missouri into northeastern Arkansas and then working its way down towards northeast Texas. At this point in time, the GFS shows a positively tilted trough. Now, let's move ahead to, this would be the GFS model for Friday evening. And notice the low pressure here along the southeast coast, and that cold upper trough again is moving in. We have a lot of cold air, and the storm continues to strengthen or get stronger. On the 500 millibar chart, look at this upper level ridge that you have positioned over the southwestern U.S., extending northward, the ridge axis northward into western Canada. Got this deeply amplifying trough with starting to become more of a neutral tilt now, where the trough axis extends north to south, straight north-south. We got a lot of positive vorticity advection, a lot of PVA indicated by these orange colors out ahead of that trough axis. That's where you'd expect the greatest vertical lifting. Moving ahead now to, this would be Saturday morning, 1 a.m. Eastern Time, the 29th of January, 2022. Now look at this low pressure system. It continues to move generally east-northeast, actually more north-northeast rather, and you're seeing now a changeover from rain to snow across southeastern Virginia by 1 a.m. local time. Friday night into Saturday morning, storm's intensifying, working its way off the coast, and this neutrally tilted upper level trough is positioned from Ohio, and the trough axis goes down through Georgia, down through the Panhandle of Florida to the northeastern Gulf of Mexico. Out ahead of the trough axis is where you're going to get all the rising air motion. Now, going ahead to, this would be 7 a.m. local time, Saturday morning, 29 January. This area of low pressure, the central pressure on the GFS model down to 982 millibars, and you have a major swath of snow from eastern Massachusetts all the way down through New Jersey, Delmarva area, down through southeast Virginia, northeast North Carolina. So the frozen precipitation shield is quite extensive. The storm is very strong. Got a lot of cold air, even working its way all the way down to Florida. There's talks of Florida this weekend that parts of Florida may get down into the 20s overnight. So that just goes to show you how much cold air is involved with this particular system. Look at where the shortwave trough axis is. It's still looking at mainly a neutral tilt, north-south orientation of the trough axis from western Pennsylvania down just off the coast of the Carolinas. Now let's take a look at the Canadian model. Very similar setup here on the left for Friday the 28th of January. This is for 1 p.m. local time on Friday afternoon. You see a little bit of a difference in the placement of where the storm develops. This is a little bit further south on the Canadian as compared to the GFS, and the central pressures at 1013 millibars. Not much of a difference from the GFS as far as the central pressure. We see that we have a shortwave trough, and these orange colors are the positive vorticity advection, higher vorticity values. Shortwave trough extends from basically the southern point of Lake Michigan down through southern Illinois, down into right around the Memphis area, parts of northern Louisiana and East Texas. Moving ahead now to, this would be Friday night at 7 p.m. local time. You see the area of low pressure in the Canadian model it's now down to 1007 millibars, a 5 millibar pressure drop in a 6-hour period, and we see that very cold air, the upper level trough, the cold trough, moving southeast. We have a 1,035 millibar high over eastern Iowa, continuing to pump in the colder air in the low levels of the atmosphere. The upper level trough, the shortwave trough, is located from Michigan down through Indiana, down through central Tennessee and into Mississippi. A lot of positive vorticity advection out ahead of the shortwave trough axis, as we'd expect. Now, moving ahead on the Canadian to, this would be 1 a.m. on Saturday morning, the 29th of January. Now we really have a storm rapidly intensifying off the coast. This thing is really going now. It's now dropped 10 millibars in 6 hours. It's now down to 997 millibars central pressure. We have snow that's developed on the northeast side of it over southeast Virginia, parts of northeastern North Carolina up to Delmarva and southern Jersey. And we have an upper level trough, shortwave trough, a neutral tilt from western Ohio down through eastern Kentucky, eastern Tennessee down through Georgia. And then finally, actually, I got a couple more slides on the Canadian. Actually, this is the last one. This would be 7 a.m. The graphic on the left here is 7 a.m. Look at the surface low pressure here, 982 millibars, due east of Vacapes, and we have very intense bands of snow now along the immediate coast of northeastern North Carolina, southeastern Virginia by 7 a.m. Eastern Time on Saturday morning, up through Delmarva and New Jersey, starting to move a little bit further to the northeast over Connecticut, Long Island, as well as up into southeastern Massachusetts. And then later on, this is early afternoon on Saturday, around 1 p.m. Eastern Time, we're not talking about a very intense low that looks like 961 millibar low, and very cold air on strong northerly winds blowing down the fetch of the Chesapeake Bay into southeastern Virginia. Very heavy snowfall at this point, continuing across the mid-Atlantic, the southern mid-Atlantic, up through southern New England. Now let's take a look at the European model. Starting off with Friday afternoon. This is early afternoon on Friday. We see an area of low pressure starting to get developed there east of Florida. Here's the vorticity map, the 500 millibar, 18,000 foot level, showing a shortwave trough axis from southern Illinois. More of a neutral tilt at this point on the European already, extending back to a little bit more of a positive tilt at the tail end of the trough. And then the next slide, this now shows the European model forecast for Friday evening at 7 p.m. Eastern Time. The area of low pressure is now well developed, 1,002 millibar central pressure. The cold air is just off the mid-Atlantic coast with this cold upper level trough. And then look at the 500 millibar level, the 18,000 foot level. The shortwave trough is extending from Indiana down through East Kentucky, East Tennessee, into parts of Georgia, down all the way to the Florida Panhandle. So we have a lot of energy involved with this trough. 1 a.m. on Saturday morning. Okay, this would be overnight, late Friday night. We see a swath of heavier precipitation along the immediate coast of southeast Virginia, northeast North Carolina, extending northward to the Delmarva. 989 millibar low pressure system located just to the east of Outer Banks. And then we have the upper level supporting the surface low, or the surface storm, intensifying. We have this tightly wound upper level trough, neutral tilt. But you notice some of these solid dark black lines here, which indicate the height contours. It appears this thing is about to start closing off. Later in the day on Saturday, now we're at 7 a.m. on Saturday morning, 7 a.m. Eastern Time. We're looking at a 978 millibar low pressure system to the east of Delmarva over the western Atlantic, and we have heavy wraparound moisture from southeast Virginia all the way up into New England, all the way up to Massachusetts, including Long Island, New York City. And then you just see this thing is just so tightly wound, a lot of vorticity rotating around the base of the shortwave trough. About to completely close off at this point and become a closed low at 500 millibars. And then finally, this is early afternoon on Saturday, the 29th of January. There's still some lingering moisture hanging on. 12Z to 18Z, morning into early afternoon, it's still hanging on in southeast Virginia, up the coast of New Jersey, eastern Pennsylvania, southeastern New York State, Long Island, Manhattan, New York City, Connecticut, Rhode Island, Massachusetts, up into Maine. And look now, we have a closed low at 500 millibars positioned just off the coast of New Jersey by early Saturday afternoon, the 29th of January. So now, taking all the models into account and potential forecasts, let's look at the snowfall maps. This is the 18Z GFS model in the upper portion of the slide. On the bottom, I have the 12Z Canadian model. So we're looking at the global models. And in general, the latest 18Z GFS model shows anywhere from 8 to 10 inches of snow across Hampton Road cities in southeastern Virginia. And you can see some of the heavier snow also extends back into parts of northeastern North Carolina. When we look at the Canadian model, very similar output at 9.7 inches for Virginia Beach, 8.5 inches out further west towards Chesapeake and Suffolk area. But it's still an interesting system. It's still an impactful system for sure. And then the European model, this is from the 12Z run today on 25 January, showing a swath of 9 to 11 inch snows across Hampton Road cities. And then the further north you go, up towards Delaware, you're just going to get clocked. I mean, 18 to 28 inches of snow. Are you kidding me? Now, of course, this is far enough out in time. These totals, no doubt, are going to change. But it just goes to show you how the system intensifies, and the track off the coast is really going to be very critical as to how much snow really falls. So, my final thoughts on tonight's video. The confidence is increasing for a significant winter storm this Friday, 28 January, and this Saturday, 29 January, 2022. We can expect lots of changes in the snowfall amounts over the next 48 hours. These type of systems take well within 48 hours. Sometimes they take within 24 hours. It takes up to within 24 hours of the actual event to really pin down the snowfall accumulation totals. So the models are going to be wavering a lot. The European and Canadian models are more robust with the upper level dynamics, with that shortwave trough at 500 millibars or 18,000 feet, and also more robust with the snowfall potential across southeastern Virginia. Now, GFS has come around to be closer to the European model at this point, based on these snowfall forecast charts. Again, 18Z GFS up is the top image, 10 inches for Hampton Road cities, and then the Canadian's 9.7, and then the European is 10 to 11. So they're all within a similar range right now, but I honestly don't expect that to stay the same. We could wake up tomorrow morning and it could be a whole different story. Now, the storm track is very similar, in my opinion, to December 2004 storm, the December 2010 storm, and the January 2018 storm, with a very rapidly deepening low pressure or storm system off the mid-Atlantic coast. Very similar. Let's take a look. Okay, there's our storms again. 2004 on the left, 2010 in the middle, 2018 on the right. And now look at the forecast charts. Very similar, very similar, and very similar. So it's going to be interesting to see how this compares. This event compares to what happened during those three previous storms. Now, the location of the phasing of the energy between the northern and the southern streams is going to be very critically important, as well as when the shortwave trough becomes negative. We talked about the negatively tilted trough and the importance of it. It indicates a much more intense storm system. And with a much more intense storm system, there's a good tendency the storm is actually going to slow down in forward speed if it's super intense. Okay. So at this time, model guidance suggests phasing. Now, the model guidance from today, 25 January 2022. We could wake up tomorrow morning on Wednesday, 26 January, and this could all be changed. But as of right now, the model guidance suggests phasing and negative tilt to the trough, the upper trough, resulting in a deepening or intensifying surface cyclone or storm off the coast of the Carolinas on Friday, 28 January. And there's still time for models to change as far as storm track, which will have a huge bearing on snowfall amounts. And we are entering that higher resolution mesoscale model time frame now. So we're getting within the range of the NAM, the Canadian regional models. We're getting within the range of these higher resolution models, which tend to pick up on smaller details. And so we'll keep watching those models. Now, at this time, based on the storm track, the latest model storm track guidance, as well as the intensity of the storm and the speed of movement, the forward speed of movement, very important, we are expecting right now 6 to 10 inches of snowfall for southeast Virginia, including Hampton Road cities, Friday night and Saturday, with the heaviest amounts along the coast. And that is mainly due to the fact that, along the coast, you're going to be closer to the higher amounts of liquid available, precipitation available. Now, the snow to rain ratio, typically 10 inches of snow equates to about 1 inch of liquid rain. When you're closer to the coast, you got higher values of that liquid available to be lifted, and therefore you have highest amounts closer to the coast and closest to the storm track. What we're expecting initially on Friday afternoon is rain, and that will eventually transition to all snow after 8 p.m. on Friday night, and then it will continue to snow overnight Friday night into Saturday morning, and we could see potentially heavy bursts of snow overnight Friday night into Saturday morning. And if we do see that, we're looking at the rates, possible 1 to 2 inches of snow rates per hour. And so as you can see, it wouldn't take, if you get those kind of heavy bursts for a 5 or 6 hour period, the totals do add up relatively quickly. Now, the majority of the models right now are indicating 6 to 8 inches of snow for Hampton Road cities. One thing for sure, travel will become hazardous again across southeastern Virginia overnight Friday night and Saturday. So as of right now, this is the latest information on the storm, and I like to use the 3 terms that are really going to determine our snow amounts: storm track, storm intensity when it goes parallel to the coast here in the mid-Atlantic, as well as the forward speed of movement. Those are the 3 key areas. Additionally, we already talked about when does the trough, the upper level trough, at 18,000 feet or 500 millibars, when does that become negatively tilted? If it's further back west, the storm system will track closer to the coast. If it's more negative tilt sooner, further to the west, expect a more close track to the coast for the storm. If it is not until it gets out, becomes negative when the storm starts developing over southeast of the Carolinas, then it might be a little bit further out, basically when it moves parallel to the mid-Atlantic coast. So there's a lot of factors here to consider for this storm. It's still very possible that the best dynamics, when that negative tilt kicks in and the storm really rapidly intensifies, there's still a potential that could occur north of southeast Virginia. And in that case, you'd have the heaviest snow amounts basically from Delaware, Maryland area up through New Jersey and north to New England, and maybe only a couple inches in southeastern Virginia. Confidence is increasing that we will see some form of wintry precip in the southeastern Virginia area and Hampton Road cities. It's just right now, again, we just have to, it's a waiting game, right? Just like the last storm last weekend. It took a while for the models to really sync up. It took to within 24 hours of the storm, in all honesty, for the models to really kind of get in really good consensus on the situation. So that wraps things up tonight in my special video. Hopefully you really enjoy these videos. Subscribe to my YouTube channel. We certainly appreciate it. Thanks for everybody's time tonight. And until next time, stay safe and God bless.